All right, so let's do a little ACT review here of some basic things. The first, the number system. Numbers, all numbers in the world are made up of complex numbers. Okay, once you have your complex numbers, there are two sides of that. There are your reals and your imaginaries. Okay, there are your reals and your imaginaries. Now, your imaginaries are the ones that include things like I, which remember is equal to the negative square root of 1, or I squared is equal to negative 1, right? But over on the real side, we have a whole bunch of other things going on. First, when you have your real, you're talking about two different types. You have your rational and irrational.
And then go into this.
Rational, and then... Okay. You're fine. You have your rational and your irrational. I'm going to label that just IR for irrational. Now remember, your rational are anything that can be shown as a fraction. Sorry, I meant that to be a B. Any number that can be represented as a fraction, even if it's something like 1/3, 1/3, that's 0.333333 repeating, it's still a rational number because it can be represented as a fraction, whereas the number pi can't. The other number that can't be represented as a fraction would be, say, the square root of 2. That also can't be represented as a fraction. So we're going to put that whole piece up there now. Now let's go ahead and talk about another set of numbers underneath the rational and irrational. Under the rational, basically only have two more categories. They're integers, which is anything without a decimal. So -5, -12, 0, 1, 22, any of those. No decimal places. And then finally and lastly, you have all of your natural numbers. Your natural numbers are which are sometimes represented like this, with a double, that's bad. Let me try that again so you can see the symbol for natural numbers. An N with a double line down the middle. And those are only your positives. Positive only. So that'd be your 1, 2, 3, and so on. Okay, so that's just something you want to try to keep track of. There will be a question on there that'll have that, so however you want to try to write that out and try to remember it, do that, but be sure you write that out right now, okay? Okay, the next question look at is kind of a tricky percentage score. If Jane on her first test got a 72% and on her second test got an 81%, the question being what percent increase did she have? I'm going to write this down because it's important. What percent increase did she have? Okay, so now this sort of by itself is a rough question because it's a little misleading. You'd be first tempted to just go 81 minus 72 and get 9. However, if you did that, if you said 81 minus 72 equals 9, so she increased by 9%, you're wrong. Because it's not asking about percentage points. Well, how many percentage points? So notice the difference. If we had said percentage points, then yeah, sure, you went up by 9 percentage points. However, she's saying what percent increase, so you almost want to think of it as if this was money or dollars, because that's where you would have classically seen something a little less confusing. So if you had, say, seen a product was $72 and it was now selling for $81, what percent did the price increase? So now you would still need that same, so the difference is $9. Remember, percentages is about how much did it change. So that $9 divided by the original price, 72, and that's actually equal to 12.5. It's actually 0.125, 0.125, but hopefully you remembered and convert to a percentage by moving the decimals. So the actual answer is 12.5. So here I want you to try one on your own real quick. Same type scenario, except your on your first test you scored a 69%, not real great, and then on your second test you scored a 79%, certainly better. So this is first test, this is second test, certainly better. What percent increase? What percent increase did you do there? So go ahead and try to figure that one out and write it down. And we're going to go on to the next one, so just pause the video. Okay, in this next question, it's an order of operation. This is kind of a bugger and a bear. So here we go. 4 squared minus 3 minus 5 times 8 minus 2 parenthesis negative 3 minus negative 7. Okay, so that's a big mess. So you got to go order of operations on this thing. Please, let's start with parentheses, please. So let's deal with this over here. That's my big mess in parentheses. So I'm going to start by just making that a negative 2 times negative 3. The minus negative 7 turns that into a plus 7. So I'm actually going to rewrite that as a 4 and a negative 2, which is actually the same as a 2 times 4. Okay, so bring the rest of the stuff down. So what else did we have? Okay, then the other side that we had was the please excuse exponents. This exponent's right here. That'd be the next thing. So that turns into a 16, because 4 times 4 is 16. So I've got, bring all that down. So we've got what? 16, bring down the 3, bring down the 3, minus 5 times 8, then we got the rest of this, minus 2 times 4. So please excuse my is the next. So here we go. That means multiplication. Well, I'm multiplying that and I'm multiplying that. So now I've got 16 minus 3 minus 5 times 8 is 40. 2 times 4 is 8. Okay, please excuse my dear, there's no division, Aunt Sally. Well, now I've got a subtraction. So I've got 16 minus 3, which of course would be, all of this in my head, that'd be 13. And then I'm going to go 13 minus 8, which brings me down to 5. 13 minus 8, which is equal to 5. And then I've got this still minus 40, which gives me a grand total of negative 35. And gosh, I hope I did my math on that one correctly. I'm pretty sure I did. Okay, in the same vein, I'm going to ask I would like you to try this. 7 squared minus 8 times 3 plus 2 times 5 minus negative 8. Okay? order of operations, work it through carefully, work it through slowly. And now I've only got one to do with you. It's a fractions converting question. 5 boxes, each one is, you've got 5 boxes. Each box is 2 3/8 feet tall. The question here is, if you had a room 12 feet tall, how much room is left at the top between the ceiling and the top box? Well, of course, we could try to do this thing out by hand, but that would be, I think, kind of a waste of time, because ultimately what we're talking about is here we got this tall room, and then we got all these boxes, 1, 2, 3, 4, and there's some amount of room up there at the top. I would probably recommend you take that and convert it into a fraction or into a decimal. So let's, real quick, just for sakes, let's take this thing and go on your calculator. What is that? What is 3/8? 3 divided by 8 is equal to, as a decimal, 0.375. So that's 2.375 feet tall. Multiply that number times 5. 2.375 times 5, and you've got 11.875 total feet. Okay, so how much room is left at the top? Just go 12 minus your answer, and you've got 0.125 at the top. Now, of course, it's saying, well, what is that in inches? So if that's, we got to sort of convert that thing back. You could, of course, check, well, 1 inch would be, let's see, what is 1 inch of 12? That would be equal to 0.0833 feet. Or then, well, 2 inches of 12 would be 2 divided by 12 is 1.16. So we're somewhere between like 1 and 2 inches, and I would say your answer is closer to 1 inch. So there you go. All right. Hope that was fun for you. Oh, you want to take that same scenario, but 6 boxes. And each box is 2 feet. 2 feet and 2 1/6 feet tall. And your room is 15 feet total. Okay, so try to work that one out. 6 boxes stacked up, 2 1/6 feet tall. How much room is at the top? All right, so when you got, here's your 6, 1, 2, 3, 4, 5, and 6. How much room is here? That's your question mark. Okay, all right. Good luck.